welcome to True Projects. In this video, we are going to explain about the project, which is an efficient computational risk prediction model of heart diseases based on dual stage stacked machine learning approaches. So, before getting into the execution, first let us understand what is the project about. So, you all know that heart disease is a major issue, right? It is a huge problem globally, causing 17.9 million deaths globally each year. That is about 32% of all the deaths. It's really concerning when you think about how many people are affected. There are various types of heart diseases, and one of the most serious one is coronary heart disease. Those who suffer from it often deal with tough symptoms like dizziness, shortness of breath, which just goes to show how important it is to catch these issues early on. While lifestyle changes can make a big difference, like eating better and exercising regularly, the cost of treating heart disease are becoming a significant issue. Experts believe these costs could go beyond $1 trillion by 2035. This really highlights the urgent need for affordable solutions that can help people manage and prevent heart disease without breaking the bank. Moving on, the cost of the treating heart disease makes things even more challenging. Globally, it is estimated that these expenses will surpass 1 trillion by 2035, and that too in the United States. We are already spending of about 229 billion each year. This financial burden really highlights how crucial it is to find affordable ways to diagnose heart disease early and predict the risk effectively. We need solutions that won't just help the treatment but also makes early detection more accessible to everyone. When it comes to diagnosing heart disease, traditional methods can be pretty expensive and take a lot of time. With so many people affected by heart disease and the rising cost of managing it, we really need a better solution. What we are looking for is a way to diagnose heart disease that not only efficient and accurate but also cost effective. It is essential to develop computational tools that can help us do things make easier for healthcare providers and identify the heart disease early and manage it effectively without putting a strain on patients. So moving on, to overcome all these problems, in this project we develop a dual stage stacked machine learning system that helps to predict the risk of cardiovascular disease using two specific data sets. So here we are proposing a dual stage stacked ensemble machine learning model using two data sets which are Hungary Cleveland and cardiovascular disease data sets. So we start by analyzing the data with classical machine learning algorithms, which are logistic regression, support vector machine, random forest, decision tree, and extreme gradient boosting. These models gives us initial predictions about risk of heart disease to make sure our results are solid and reliable. And we use tenfold cross validation technique. So we will be using tenfold cross validation technique. This process involves splitting the data into 10 parts of training the models on 9 of those parts. So here we will be training 9 of those parts and testing them on the remaining one. This way we can be more confident in the accuracy of our predictions, which will be more reliable. And moving on, to boost the performance of the models, we use two hyperparameter tuning methods. One is random search CV and the other one is grid search CV. These techniques helps us find better values for the parameters that control how our models work, which is crucial for making our accurate predictions. Once we identify the best performing model, specifically random forest and decision tree, we have combined them in a stacking ensemble model. So we have combined random forest and decision tree in a stacking ensemble technique. This method takes advantage of strengths of each model, allowing us to enhance overall prediction accuracy. Plus, it helps prevent overfitting, which is when a model learns the training data too well and doesn't perform as well as on new unseen data. By stacking these models together, we aim to create a more reliable and accurate prediction system for cardiovascular disease risk. Moving on, as an extension of this project, we have introduced an advanced ensemble model that is voting classifier to enhance the performance. This technique also combines the predictions from multiple individual models. which helps us to achieve better accuracy in our predictions. And moreover, we have built front end using Flask framework. This front end will allow users to interact with the prediction system more easily and includes features for user authentication, making it secure. The goal of this extension is to make the heart disease prediction system more accessible and practical for real world use, allowing for the effective testing and interaction by the users. So, coming to the implementation of the project, we have followed the steps of flow of work to implement the project. So, coming to the first step, we have imported the packages that are required, for example, NumPy, Pandas, Seaborn, Matplotlib, sklearn, etc. And then we explored the data set. So, we have loaded two data sets, that is Cleveland, Hungary, and the cardiovascular disease data set. And we understand the structure and contents in the data set. Then we do data pre-processing, which involves converting data into Pandas data frame, and we have dropped unwanted columns that are unnecessary columns. And we visualize the dataset using Seaborn and Matplot libraries. So these are the libraries using which we can do the visualization. And we have converted categorical into numerical variables using this label encoder technique. And we have selected important features. Then we split the data into train and test sets, where train set is used to train the models and test set is used to evaluate the models. Then we have built the models. After building the models, we fit it with the train set. Then we evaluate them using accuracy, precision, recall, FN score, and we compare those using graphs. And we have developed front end using Flask framework, which is integrated with the SQLite 3 database. And in the front end, users they will be able to give the input as a feature values in the front end, and that feature values will be pre-processed at the back end, and that data will be fit with the trained model. Trained model will be used to make the predictions. So finally, outcome will be displayed in the front end whether the person has heart disease or not. Now, coming to the algorithms used, we have used multiple models which are XGBoost, random forest, decision tree, logistic regression, support vector machine, meta model, and extension voting classifier. So in the meta model, we have combined random forest and decision tree, which is a stacking classifier. So meta model is nothing but here stacking classifier. In that, we have combined random forest and decision tree. And the extension model voting classifier has got the highest accuracy. So we have deployed it in the front end to detect the heart disease. Coming to the requirements to implement, we need hardware and software requirements. In hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements which are needed are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now we need to open the code folder to execute it. So let's open the code folder. These are the source code files of the code folder. So let's understand them. In the archive folder, we have the Hungary Cleveland dataset. So let's open it. So this is the dataset that is used in the project to train the models to predict the heart disease. And these are all the independent variables. So for example, we have age, sex, chest pain, resting BPS, cholesterol, fasting blood sugar, resting ECG, maximum heart rate, exercise angina, old peak, ST slope. So all this impact the heart disease, which we have in the target column, whether the person has heart disease or not. 0 represents person has no heart disease and 1 represents person has heart disease. Now let's close this. Getting back here in this folder, we have the cardiovascular disease dataset. So let's open it. So this is the dataset used in the project to predict the heart disease using the cardiovascular disease dataset. Getting back, in the static folder, we have CSS, JavaScript, and Bootstrap files. These files are important for the visual appeal of the project. And coming to the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have two model files which contain the algorithm information. These will be loaded into the project code during runtime. And here we have two notebook files which are the Jupyter notebook files. So these files, they contain the code So these Jupyter Notebook files contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it the popular choice for the data science. So here in this DF1 folder, we have the dataset used as Cleveland Hungary dataset. So all the models will be built on the Cleveland and Hungary dataset, and we will be able to predict the heart disease based on that dataset. And coming to DF2 dataset folder, DF2 Jupyter Notebook file, in this we will be using this cardiovascular disease dataset, and all the models will be trained according to that dataset, and we will be predicting heart disease based on that. And here in this sign up, this is the signup.db file. This file is a database file which is used to store the user information. And here we have two sample files. In this, we have the test cases that we will be using in the front end to detect the heart disease. So this DF1 contains the test cases related to Cleveland and Hungary, and this DF2 contains test cases related to cardiovascular disease. So now copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open Anaconda prompt. Anaconda prompt is open. Now using the command cd followed by the space, paste the copied path and click on enter. This will change current directory to the code folder's path. So now we need to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome. Here we need to paste the link and now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So let's register first. Click on register. Here we need to fill in all these inputs, all this sign up details, and then get registered. I have already registered, so I'll directly log in. So click on login, give your username and the password, and click on login. We have logged in successfully and we are redirected to prediction page of the project. So we are doing prediction for both the data sets. So we will be doing prediction here for both the data sets. So click on DF1 prediction so that now we will be doing prediction for the heart disease based on Cleveland and Hungary dataset. So these are the inputs need to be given. Let's understand them first. So the first parameter which we have is age, that is the age of the patient, typically measured in years, which can influence the risk of the heart disease. The next one we have is sex, that is the biological sex of the patient, male or female, as it can affect the cardiovascular risk factors. Coming to chest pain type, it is a category of chest pain experienced by the patient which helps in assessing the likelihood of the heart disease. Coming to resting BPS, it is the resting blood pressure of the patient measured in the mmHg, indicating cardiovascular health. Coming to cholesterol, it is a total cholesterol level in the blood, as high levels can increase the risk of heart disease. Coming to fasting blood sugar, it is a level of glucose in the blood after fasting, which can indicate diabetes risk, and it impacts on the heart health. The next one we have is resting ECG. It is the results of an resting electrocardiogram, which measures the electrical activity of the heart and can reveal the abnormalities. And the next one we have is maximum heart rate. It is the highest heart rate achieved during exercise, reflecting heart's capacity and response to physical activity. Exercise angina. It indicates whether the patient experiences chest pain during physical exertion, which can be a sign of heart disease. Old peak is a change in ST depression induced by exercise compared to rest, which helps assess the heart function during stress. ST slope. It is a slope of the peak exercise ST segment, which can indicate the presence of ischemia or the other heart conditions. So we understood all these parameters. Let's enter them. For that, open the sample test cases. As we are doing prediction for the DF1, let's open the sample DF1 sample file. So these are the inputs that need to be given. These are the different test cases. So let's enter them. So let's try with the first test case. So where age of the person is 61. And the next one we have is sex, that is nothing but 1, which means person is male. Chest pain type is 4. Resting BPS is 160. Cholesterol value is 0. Fasting blood sugar is 1. Resting ECG is 1. So here we are supposed to give the resting ECG. Then the next one is maximum heart rate. So maximum heart rate is 145. Exercise angina is 0. Old peak is 1. ST slope is 2. So now click on predict. The input will be pre-processed at the backend and then we will be getting the prediction. So here we got the prediction that positive, which means patient is suffering from the heart disease. Patient report has been predicted as positive. It impacts that it shows that person is suffering with the heart disease. Now let's try with the one more test case for the same data set. So click on DF1 prediction. So now let's try with this test case. That is the fifth test case where age of the person is 60. So the next one, sex is 0, which means person is female. Chest pain type is 4. The next one is testing BPS. It is resting BPS. It is 150. Cholesterol is 258. The next one we have is fasting blood sugar, resting ECG. Maximum heart rate is 157. Next one, exercise angina is 0. Old peak is 2.5. Sorry, it is 2.6. ST slope would be 2. Now click on predict. So here we got the prediction that patient is having heart disease and here it has been predicted as positive. Let's try using one more test case. So click on DF prediction. So let's try with this test case. This test case where age of the person is 55, gender would be 0, and the chest pain type is 2. Resting BPS is 122. Cholesterol is 320. Fasting blood sugar is 0. Resting ECG is also 0. Maximum heart rate is 155. Next one we have is exercise angina, that is also 0. Old peak is 0. ST slope is 1. Now click on predict. So based on the given information, now we will be getting prediction as negative. So here we got the prediction as negative. That means patient is not suffering from any other heart disease. He's completely normal. Now let's do prediction using the other data set, that is DF2 prediction. So here also we'll be having the parameters. So the first one, age, represents the age of the person, which we understood already itself. And here gender of the person. And the chest pain, we heard it about in the last data set itself. And here we have is resting BP. It is the resting blood pressure of the patient measured in mmHg, which provides the insights into cardiovascular health. Coming to resting serum cholesterol. So, serum cholesterol is the level of cholesterol in the blood, as elevated levels are associated with the increased risk of heart disease. Next one we have is fasting blood sugar. We have heard it about already. Resting re-electro. So coming to that, it is resting ECG. It is the results from resting electrocardiogram, which records the heart's electrical activity and it can reveal the abnormalities. The next one we have is maximum heart rate. So coming to exercise angina, it indicates whether the patient experiences chest pain during physical exertion, which may signal underlying heart problems. We have is the next one we have is old peak slope. We also heard it about it already. Number of major vessels. So these are the number of major coronary arteries that show significant narrowing or blockage, providing insights into the severity of the heart disease. So this is all about the parameters. Let's give inputs to these parameters. So open the DF2 folder. So these are the parameters need to be entered. So let's try with the first test case where age of the person is 44. The next one are supposed to enter is the age. Age is 1. Sorry, gender is 1. Chest pain is 0. Resting BP is 147. Next one we have is serum cholesterol, which is 487. Fasting blood sugar is 0. Resting electro is 1. Maximum heart rate is 179. Exercise angina is 0. Old peak is 3.1. And the slope is 2. Next one we have is number of major coronary vessels that is 1. Now click on predict. So this input will be pre-processed at the backend and fit with the trained model, and then we will be getting the prediction. So here we got the prediction as positive, which means patient is suffering from the heart disease. So now let's try with one more test case, that is the second test case. So click on DF2 prediction, where age of the person is 29, gender would be 1, which means person is male, and the chest pain is 0. Resting BP is 152. Serum cholesterol is 138. Fasting blood sugar is 0. Resting electro is 0. Maximum heart rate is 199. Exercise angina is 1. Old peak is 0. Slope is also 0. Number of major vessels are also 0. Click on predict. So here we got the prediction as negative, which means patient is not suffering from any heart disease. Let's try using one more test case. So let's try with this fourth test case. Click on DF2 prediction, where age of the person is 61, 67. And the next one is the gender. It is 1. Chest pain is 0. Resting BP is 165. Serum cholesterol is 234. Fasting blood sugar is 0. Resting electro is 0. Maximum heart rate is 168. Exercise angina would be 1. Old peak is 5.6. Slope would be 1. Number of major vessels are 1. Now click on predict. So now we got the prediction that patient has no heart disease, and here the report is negative. Let's check with the graph. So here click on graph. So this first we have for the data set 1. So this is the sample outcome graph, where on x-axis we have target and on y-axis we have the count of each class. This shows the distribution of the class. And here we have the correlation matrix. So this is the correlation matrix which shows the correlation between two independent variables. So two variables. And this is the accuracy comparison graph. Here on x-axis we have the accuracy score, and on y-axis we have the all algorithm names. If you observe, the voting classifier is having the highest accuracy than any other model. Moving on, this is the precision score comparison graph. This is recall score. This is F1 score, RC, AUC, Cohen-Kappa score. And all these are the metrics used to evaluate classification models. And here we have for data set 2. So this is the data set 2, which is the cardiovascular heart disease data set. This here also on x-axis it represents target value, and on y-axis we have count of that target value. And this is the correlation matrix, which shows the correlation between two variables. And this is the accuracy comparison graph. Here we have precision score, recall score, FN score, ruc, auc, cohen kappa. And if you observe here also, extension model is having bit accuracy higher than any other models. So now let's click on logout. In this way, by using fine-tuned machine learning models and the ensemble models, we will be able to predict the heart disease well. So with this, doctors and patients, they will be benefited for diagnosing earlier the heart disease. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.